Hey, Geometry. So we're continuing our first section of Unit 4 on conditional statements. And we're going to look at negation of statements. So a single statement, not an entire conditional statement, but a single statement, we can negate it. But what we're going to do is we're going to do the opposite of that original statement. So it's just formed by denying the original statement. We can just say in symbols, we could say not P, or we can write it as this little like tilde, little wavy symbol, and that also means not, and so that's negating things. So if the statement is it is sunny, the negation of that, it is not sunny. Just get that not in there in the right spot and you got it. This next one, the measure of angle A equals 20 degrees. Well, the negation of that would be the measure of angle A is not 20 degrees. All right, so we need that for our inverse. So we already did our conditional statement, our original conditional statement. We did the converse, where you swap the two. The inverse is where you negate the two. You negate the hypothesis and conclusion. So if the original statement was if P then Q, right, if that's our original, then our inverse of that would be not P then not Q. If not P, then not Q. So we're going to look at some examples of that, but we're going to go ahead and throw the last one in here as well. All right, so we've got the original statement, the converse, the inverse. Finally, we have the contrapositive. The contrapositive does both kind of what the converse does and the inverse does. It swaps and negates. The contrapositive of a conditional statement is formed by negating and switching the hypothesis and the conclusion. So if my original was if P, then Q, our contrapositive would be if not Q, then not P. All right, we flip them and we negate both. So we're going to kind of go run through each of these for the following examples. We're going to go through the converse, the inverse, the contrapositive, and then write the truth value of each statement. So this first one, the converse, the original statement is if two angles are vertical, then they are congruent. The converse would be if two angles are congruent, then they are vertical. Then they are vertical. So we could now analyze our original truth value. If two angles are vertical, then they are congruent. That statement is true. Vertical angles, if we have them, two whatever angles on top of each other, those opposite angles, vertical angles, are congruent. That's a true statement. However, if two angles are congruent, then they are vertical. Not necessarily. You can have congruent angles that are just side by side. They're not necessarily vertical of each other. So that statement is false. We've got a counterexample. The inverse will negate. So the inverse is if, and then we're going to negate this first statement, two angles are not vertical. So we got two angles that are not vertical, then they are not congruent. Let's use our congruent symbol. And so we have two angles that are not vertical, right? They're not sharing that vertex opposite from each other. Can we necessarily conclude that they're not congruent? No, you actually could have those congruent angles that are not vertical from each other. So that statement is also false in this case. The inverse and the converse, both false. But the inverse is negating both statements, both negating the first statement and the second statement. Finally, the contrapositive. Positive. That does both. We're going to swap and negate. So if two angles, and then we could say are not congruent. Just use my symbol here. Then they are not vertical. All right? And this can get tricky to kind of think through. That's why we call this this logic. We kind of reason through thinking this out. If two angles are not congruent, so they are different sizes, their measures are different sizes, different values, then they are not vertical. Well, if the two angles are not the same measure, it would be impossible for them to be vertical. So this statement is actually true. The contrapositive is true in that case. So maybe pause the video, try these ones on your own. I'll come back in a moment and you can check all your answers. So go ahead and try that, and there they are. So you can kind of read through and check through those. Let's go through each and assess the truth value of these statements. Our original statement, if you live in Florida, then you live in the United States. So I'll give that a T for true. The converse would be, if you live in the United States, then you live in Florida. Not necessarily. We're counter to that. So that's false. The inverse would be, if you don't live in Florida, then you don't live in the United States. Also false. There are, we have plenty of counter to that. And then contrapositive. If you don't live in the U.S., then you don't live in Florida. That statement is actually true. So if you don't live in the U.S., then you don't live in Florida. The last set, if it is raining, then we will not practice outside. Let's accept that as truth. Let's say we're doing some sport where, if it's raining, they don't practice outside. If we will not practice outside, then it is raining. We could probably come up with some counter to example to that. Maybe it's snowing. Maybe there's some other condition, too hot, too windy, or something like that. I don't know what's going on, but there probably could be some counter to that. But I could understand there might be some argument that might be the only reason you wouldn't practice outside. And then similarly, if it is not raining, then we will practice outside. Again, there might be other reasons that you'd be inside, so that statement we'll treat as false. Finally, if we will practice outside, then it is not raining. Well, if this original statement is true, if it's raining, then we'll not practice outside, then this statement is true. If we will practice outside, that must mean it's not raining, so that statement is true. In fact, we'll see always that the contrapositive is an equivalent statement to the original. So the contrapositive of a conditional statement is true if the conditional statement is true. And so if they're both true and in kind of all cases, then that we call equivalent statements. The conditional statement is equivalent to its contrapositive. And then furthermore, we also see that the converse and the inverse of any conditional statements are equivalent. Their sign will always match. They'll always either be true together or false together. Kind of your disproof for both can be the same. But those two are equivalent. So if one's true, the other will be true. If one's false, the other will be false. And that wraps up our section on conditionals.